Welcome back to Quay Does Leetcode. Today I'm going to be doing problem number 124, binary tree maximum path sum. So for this problem, you are given the definition of a path, and a path in a binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them, and a node can only appear in the sequence at most once, and the path does not need to pass through the root. So a path could be, for example, 1, there are 3 possible paths. You could have 1 and 2, that's one path, or you can have 1 and 3, that's another path, so 1 and 3, or you can have 2, 1, 3, that's another path. The path is, the path sum is the sum of the node's paths, the sum of the node's values in the path. So for this path 1 and 2, the path sum is 3. For this path 1, 3, the path sum is 4. And for 2, 1, 3, the path sum is 6. So you need to return the maximum path sum of any non-empty path, the maximum path sum of any non-empty path. So in this case, the 3 paths are 1, 2, 1, 3, and 2, 1, 3. So the max, you see there's 3, 4, and 6. So the max is 6. So another thing to consider is that you can also have negative numbers, and a node can be negative. And so in example 2, the root node is negative. So you don't want to include the root node because it's going to give you a lower value. So the paths are, you can have this path, or this path. This path. Or you can have 10, 27, or you can have negative 10, 27, or you can have negative 10, 20, 15, or you can have or you can have 15, 27, or you can have 15, 20, or 27. So there's a lot of paths you can make, but the optimal path is 15, 27, because if you add that up, you get the highest sum. So how can you go about solving this problem? Well, you can go through and recursively and build all the paths and keep track of what your max path is. So how can you build a path recursively? Well, what if you're on a node that is none? Well, if you're on a node that's none, then then the max path is 0. So that's the base case. If there's no node, then the max path is, the path that you can make from that is 0. The sum path that you can make from that is 0. But what if you're on a node? So if you're on a node, so we want to start from the bottom and work our way up to the tree. And we want to make the paths. So there's two ways to make a path. You can either, the max path, you can either go left, go right, or you can go both. But if you go both paths, then you are splitting, and the node above it, you can only split once, because the node above it, if you try to make a path with the node above it, you obviously can't go you can't go backwards, so you can't make a path. You can't have a path that goes like this. So you can only split one time. So you can go left, you can go right, or you can split. And then if you go left and you go right, you have to pick the max path. The max would be the max of the left and the right. So 15 plus 20, or 20 plus 7, so that's 35, and 27. So the max would be 35. So the max is the left side. So you can take the max, or you can take both of them and add yourself. So that's 35 plus 20 plus 27. So you can either take the with a split would be this 42, or without a split would be the max of 35 and 27, which is 35. So in the recursion, what we want to keep track of is the max path without a split, because if you're going to return up to its previous node, you're going to want to not split, because you can split in the node above, and then you won't be splitting. You can only split one time, otherwise it doesn't make a path. So you want to return the without a split. So you would return to your parent this 35, and then your parent would do its max path. So it would take its max with a split. So with a split, it would do its it would do 9 minus, or 10 negative 10 plus 9, so that'd be negative 1. Or with the split, it would do this 35 minus 10, so 25. And so that would be with the split. It would do with the split, it would do 9, negative 10, and 35. And without a split, it would do the max of negative 1 and 25. which is 25. But we already saw that the max, we saw that one of the result, the max we had seen so far was 42. So we end up returning 42. So this is a little confusing, but it makes more sense when you do the code. So basically what we're going to do is a depth first search where we return the max without a split. And at the same time, we're going to be updating result based on the max with a split and without a split. So let's look at the code. So the first thing we're going to do is we're going to need to keep a global variable for our result, our max path that we've seen. So our result, we're going to start this off with being the root.val, because if there's only one node, the answer is going to be that root val. So we're going to start off with the root.val as the thing that the max path sum that we've seen so far. Now we're going to make a function for depth first search given given the root, and if not, if there's no node there, then we're going to return 0, because if you're on no node and it's empty, then the max without a split is going to be 0. Now we're going to do our depth first search. So we're going to do our left is going to be equal to depth first search root dot left, and our right is going to be equal to depth first search root dot right. So look, these are going to return, and so the node that we're currently on, we're going to get our max. So our max left is going to come from the left, and our max right is going to come from the right. And I forgot to mention that if it's negative, so let's go back to the drawing. So, whoops. If it is negative, we also want to, if it's negative, we want to have a option to include it or not, because you could either use the node or not. So, in the case of negative 10, 9, and the answer would actually be 9, because you can have a path of just one node. So you can either include the node or not. So if this 9 was negative and this 10 was positive, you could have the path with just the 10. So instead of including the 9, it could be a path of one node. So you could either include it or not. So because of that, we're going to go back to the code, and we're going to update our max left and to be the max of max left, and 0, because you can either include the node or not. If you don't include the node, you would just add 0. So max right is going to be a max of max right and 0. And then so we what we want to return is we want to return our max without a split. So you can't split. So if you can't split, you have to return the max of max left and max right. You add one of those, the max, whichever one's the most, plus the node that you're currently on, root.val. So you return the max with a split. And you also want to calculate the max without a split. So you can potentially update the result. So we're going to have the result be the max of the result and the max with a split. So you're going to add both max left and max right together. Max left plus max right plus the node that you're currently on, root.val. And this will update your result. So then you just want to return, you want to call your depth first search. So depth first search on your root, and that will update your result. So then you return your result. And let's run this. And I forgot to add, so when you're using a global variable, you need to add non-local and that variable to say this is going to be a global variable. So let's run this, and it's giving us the correct answer. Let's submit, and it is giving us the correct answer. So this will run in O of n time, for it has to go to each of the nodes once, and the space complexity is O of h, where h is the height of the tree. So if it's a skewed tree, then it would be O of n, and if it is a balanced tree, it would be O of log n. And thanks for watching, and I'll see you in the next video.